Welcome back, students. In the previous class, we completed the refraction of light and also we learned refraction of light at different surfaces, different mediums, refractive index, refractive index. It is represented by the letter N, and we know the formula N is equal to C by V. And from this formula, if you want to find V value, it will become C by N. And we also learned that C value is always constant, that is 3 into 10 power 8 meter per second. Right? But now we'll start another important topic, that was nothing but lenses. Lenses are also work on the based on the principle of refraction of light. So lenses work on the principle of refraction of light. So coming to the lens, it is two types of lenses. One is a convex lens and the other one is concave lens. So it's a transparent refracting medium. It is a transparent refracting medium bounded by two spherical surfaces. So this is one surface and this is two second surface, two spherical surfaces. So among these two, at least one, at least one is curved. At least one is curved, but here two are curved. Here also two surfaces are curved, and those are called lenses. And examples of these lenses where we have used is magnifying glasses. We'll use these in magnifying glasses, camera lenses, spectacles, and also in microscopes also. Microscopes, right? Let's move on to the types of lenses. Let's start with the first situation, that is nothing but a convex lens. Convex lens. So let's say convex lens looks like this. Two spherical surfaces. Okay. A lens which is thicker at the center. Let's say this is the center part. It is so thick at the center, thinner at the edges. It is thin at the edge, right? And this lens is also called as convex lens is also called as the converging lens. Okay, let's see. Let's say this is the convex lens. Let's draw an imaginary line. Let's say some parallel lines are coming. After refraction, what is going to happen was, after refraction, the rays diverges and meets at one point on the principal axis, right? Which means all the light rays comes and meet at one point, and this type of property we'll call it as a convergence. So when the rays are tend to come and meet at one point, and this property we'll call it as a convergence, which means it converges parallel rays of light at one point. So this mirror is also called as the converging mirror. Which mirror? Converging mirror. So coming to the convex lens, the symbol for convex lens is this. this is the symbol for convex lens. It will be more useful while drawing the ray diagrams, but right now in the textbook he hasn't used it, but he's simply using this. So we'll continue with this, and also I'll show you how to draw the ray diagrams with this also. Okay, so let's move on to the concave lens. Second type of lens is concave lens. So let's say this is the concave lens. Here two spherical surfaces were there. And this concave lens is also called as the diverging lens. Diverging lens. Let's draw a line. Let's say it is a principal axis. Parallel rays gets diverges. The parallel rays gets diverges. Right? So we have to make them to extend backward so that they meet at one point on the principal focus, and there the image is going to be formed. Like here the rays gets diverges, and this phenomenon we'll call it as the diverging, and the lens is called as the diverging lens. We have a simple trick to remember convex lens and concave lens. The trick is remember the word complex. CO for converging, alpha lens. So converging lens is X for convex lens, right? Here, similar type of word we have learned in the previous for mirrors, that is nothing but a domex. In the domex we learned D for diverging, M for mirror. Diverging mirror is convex mirror. Here again for complex. Converging lens is convex lens, right? You have to be careful with these two. Earlier, you don't get confused, and many times he is going to ask in 1 mark questions which is called as a converging mirror and which is called as a diverging mirror. And in many questions he will directly give without giving convex mirror or concave mirror. He simply say a converging mirror is used in the following diagram. He simply say you need to remember which is a converging mirror and which is a diverging mirror, and which is a converging lens and which is a diverging lens, right? So simply remember domex for diverging mirror is convex mirror and converging lens is convex lens, right? Quite opposite. If the diverging mirror is convex, then the converging mirror is concave. Here converging lens is convex and the diverging lens is concave. Did you get it? Okay. Let's move on. Let's see the parts. Before going to the parts, let's see the types of lenses. It was the most important question, and sometimes he might ask in 1 mark and 2 mark questions also. Draw the types of diagrams. Draw the different types of lenses. Let's start with the convex lens. Convex lens. Let's say if the two spherical surfaces were equal, these two are the two spherical surfaces. If these two spherical surfaces were equal, we'll call it as a equiconvex lens. Okay. Among these two, if one of the spherical surface is bigger and the other one is a little bit shorter, we'll draw a straight line, we'll get like this. Right? It is called as the biconvex lens. Which lens it is? Biconvex lens. Equiconvex lens means it has the two spherical surfaces and those two surfaces are equal. And what about the biconvex lens means? Two spherical surfaces, one is bigger and the other one is a little bit shorter. Right? Let's move to the third situation. If you cut this lens into two pieces, what happens? We'll get this and middle part like this. Another also it will be like this, right? So it's a one curved surface, one plane surface, right? It is also called as a plano convex lens. What do you call it? A plano convex lens. And coming to the final situation, we have a different types of mirror. One convex surface and one concave surface. It is also called as the concavo convex lens. What do you call it? Concavo convex lens. So let's move on to the concave lens. Here this is called as a concave lens. Okay. Here in this concave lens, if you draw exactly the middle, it looks like if both the spherical surfaces are equal, we'll call it as an equiconvex lens. What do we call it? Equiconcave lens. Equiconcave lens. If one is bigger and the other one is a little bit shorter, we'll call it as a biconcave lens. Biconcave lens. Exactly at the middle, if you cut into two pieces again, just like the convex lens, we'll get a concave surface and a plane surface. Plane surface and a concave surface. Right? It is also called as a plano concave lens. It is called as plano concave lens. Right? Okay. And finally, firstly we have a concave surface, and next we have convex surface. And this type of lens is called as a convexo concave lens. Right? So these are all the types of lenses you have to remember. So let's move on to the parts of a convex lens and concave lens. Right? Let's move on. So let's start with the convex lens first. Do you remember the points? I think you already know the points, terms that are related to the convex and concave mirrors, just like the same thing. Here it is this line. This is an imaginary line. This line is called as the principal axis. And exactly at this point, we'll call it as a O for optic center. What do we call it? Optical center. But over there, middle of the mirror, we'll just say point P. P is called the pole of the mirror. Here this point is called as the O for optical center. And then here, this is a mirror which is the part of a sphere, right? So this middle part is a part of a sphere. So which means it has a special focus. Let's say it has a focus f1. It has a center of curvature. So instead of using center of curvature, we'll say it is 2f1. Right? So this is the second spherical surface. It also has focus f2, and it also has a center. We'll call it as a 2f2. Right? Did you understand what I'm saying now? So which means every convex lens has two focus, two centers of curvature, f1 and 2f1. f1 and 2f1 belongs to this, f2 and 2f2 belongs to this. Right? Did you get my point? Very good. Now, the distance from optical center to f1 is small f, which is nothing but focal length. Optical center to f2 is also small f, focal length. Right? Just like the same thing. Two focal lengths, two times of focal length will get 2f1 and 2f2. Right? Here, the distance from optical center to 2f1 is called r1 here, and here to here is called as the r2, radius of curvature 1 and radius of curvature 2. Right? So just like the same thing. So coming here, if you consider for concave lens also, we have two spherical surfaces. This is spherical surface number 1, f1 and 2f1. This is spherical surface number 2. This is f2 and 2f2. You get it? Exactly at the middle we have a point, and that point we'll call it as the optical center. Right? So do remember and don't forget everything. Let's see the rules for drawing the spherical lens. Sorry, rules for drawing the images formation for lenses like convex lens and concave lens. Let's see the first rule. First and most important rule is rule number one is, let's take a convex lens. Rule number one, when a light ray passes parallel to the principal axis, it diverges, it converges to one point over here. After refraction, it passes through the point, and that point will correct as a focus, right? So, parallel ray, if a light ray parallel to the principal axis, after refraction, it passes through the focus. This is rule number one. Rule number two, when a light ray passes through the focus after refraction, it passes through the other medium, that too parallel to the principal axis. Right? In the first situation, when a light ray passes parallel to the principal axis after refraction, it passes through the focus. Second situation, if it goes to the focus, it passes parallel to the principal axis. Third situation, when a light ray passes through the center of curvature, here there is no center of curvature, I hope so. Instead of center of curvature, we are going to use optical center. When a light ray passes through the optical center, it passes through the other medium without any bending. Right? Right? So optical center. Three rules you have to remember. Same these kind of three rules for concave lens also. When a light ray passes parallel to the principal axis, it looks like it diverges away. When it extends it backward, it looks like it is coming from the focus. So if you move on to the second situation, when a light ray appears to come from focus after refraction, it passes parallel to the principal axis. Clear? So next move on to the third situation. Situation number three, when a light ray passes through this optical center, here nothing to worry, it passes through the other medium without any deviation. Right? So that's it. These are all the rules you have to remember. Right? So in the upcoming video, we're going to deal with image formation by convex lenses. We'll deal with the image formation by convex lens. Okay, let me ask some questions. Which lens is used in the magnifying glasses? So coming to the convex lens application, in the magnifying glasses, we'll use convex lens because convex lens produces small and it is used to see small objects very clearly. Right? For that purpose, we'll use convex lens in the magnifying glasses. What about in the camera? Convex lens is used. It forms a real image on the sensor. And what about the microscope? In a microscope, convex lens is used to observe the distant objects. Right? So tell me, which lens is called as a converging lens? Convex lens is also called as the converging lens. Define focal length, the distance between the optical center to focus f1 or here to here f2. So the distance from here to here or here to here both are same, and this distance we'll call it as a focal length. What happens when parallel rays fall on the convex lens? So when parallel rays fall on the convex lens, it converges and meet at focus on the principal axis. Did you get it? Okay. So that's it. We'll continue the class tomorrow by drawing the ray diagrams at different situations. Okay. Thank you. And thank you all.